Okay, for section 6 in chapter 3, we're dealing with finding the distance between two parallel lines, an important part of this chapter. Now, looking at this first example, we have the two parallel lines given, and we need to find the distance. So remember that distance always has to be a perpendicular distance. So if we can figure out what is the slope of the given parallel line, then we can check the coordinates that are visible here, and we can see if any of those pairs would be perpendicular, and then we can use the distance formula between those 2 points. So, using point 0,4 and 5,0, let's figure out what the slope is. M is equal to the change in y, so we have 4 minus 0 over 0 minus 5. So the slope of the parallel line is going to be negative 4/5. So the perpendicular slope that we're looking for is the opposite reciprocal of that, which is going to be positive 5/4. Okay, so I'm going to find the slope between 5,0 and 1, negative 5. So we take the change in y, which would be 0 minus a negative 5, divided by 5 minus 1. Well, in the numerator we have positive 5, because when we subtract a negative number we know it's addition, and in the denominator we're going to have 5/4. So it is indeed the opposite reciprocal. Now if we would have used the other two coordinates, we would find the same slope, but what I notice here is that there's a misprint in our diagram. That should be a negative 4, negative 1. So just in case you were going to check the slope between those 2 points, that would be that. Now, since we know that these 2 points, 5,0 and 1, negative 5, do form a perpendicular slope, we would use the distance formula between those 2 points. So the distance formula is the square root of the change in x squared, so we have 5 minus 1 squared, plus the change in y squared, 0 minus a negative 5, so we have 0 plus 5, quantity squared. So then the distance here, let's see, we have the square root of 4 to the second power plus 5 to the second power. 16 plus 25 gives us the square root of 41. And we could get a decimal approximation for that since it says round to the nearest tenth. So let me do square root of 41. And that equals 6.4. So the distance equals 6.4 units. Okay, in this next example, we're asked to find the distance between these two parallel lines, but no lines are given, we're just given the equations. So we will need to graph those. So I'm going to graph those for you. Okay, now with the lines drawn, we need to find the perpendicular distance between these two parallel lines. So I'm going to choose that starting point, that point being 0, 5. I have 2 points on my y-axis that could be used that make it the easiest, I think. So I'm going to use the positive 0, 5. What I'm looking for is I'm looking for the point of intersection of these two lines, because if I already know I have 0, 5, so if I can find the length of that perpendicular line, that will be my distance between those two parallel lines. So what I need to do is I need to find the coordinate of that point of intersection. So in order to do that, we're going to write what is the equation of that perpendicular line. Well, it is y is equal to negative 2x plus 5. It's got to be the opposite reciprocal of the given slope, and the given slope was 1/2. So we now have two equations that intersect at that point. Those two equations are y is equal to 1/2 x minus 4 and y is equal to negative 2x plus 5. If I'm going to treat this as a system of equations, and I'm going to solve for the variables. So since they're both equal to y, I can put those two equal to each other. So we have 1/2 x minus 4 is equal to negative 2x plus 5. Adding 2x to both sides of the equation, I have 5/2 x over here, and add 4 to both sides, we have 5/2 x is equal to 9. Multiplying by the reciprocal, we're going to have the reciprocal of 5/2, we're going to have 18/5 over here for x. Let's convert 18/5 to a decimal point to make it a little bit easier for us. We got 18 divided by 5 gives us 3.6. So x is equal to 3.6. If x is equal to 3.6, we can substitute that into one of our two equations and figure out what y is. So we'll go y equals negative 2 times 3.6 plus 5. So 3.6 times negative 2 is equal to negative 7.2 plus 5 gives us negative 2.2. So y is equal to negative 2.2. Our coordinate then is 3.6 and negative 2.2. In combination with our other point, 0.5 for our distance formula. So the distance then between those two parallel lines is the square root of the change in x, so we got 3.6 minus 0 squared, plus the change in y, so that is negative 2.2 minus 5 squared. So 3.6 squared is equal to 12.96. The square root of negative 2.2 minus 5 quantity squared plus 51.84. Okay, so add that to 12.96, and we have the square root of 64.8. The decimal approximation for that is, let's see, 64.8. We have 8.05. So 8.05 is our distance between those two parallel lines.